Lesson 67, radical denominators. We know from previous problems that we cannot have a radical or a square root in the denominator of a problem. So we multiply by that same square root in the denominator so that we no longer have denominators in the square root. These types of problems, we have what is called a conjugate pair in the denominator. Okay, so we're going to have to multiply by a conjugate pair in order to get rid of the square root in the denominator. First, let's write down the definition for a conjugate pair, and then I'll show you a few examples of what they might look like. Alright, a conjugate pair is two irrational numbers. That means it's a number composed of a real number and an imaginary number. Okay, so we have two irrational numbers. Of the form a plus or minus b square root of c. Or two complex numbers of the form a plus or minus bi, whose product is always a rational number. Alright, so a conjugate pair is two irrational numbers of the form a plus or minus b square root c, or two complex numbers of the form a plus or minus bi, whose product is always a rational number. Now, conjugate pair you would think means you need two. Alright, so the reason that they are a conjugate pair is because of this plus or minus. Alright, anytime we have a plus or minus, that means that we have a plus b square root c and a minus b square root c. Alright, so those plus or minuses are actually going to help us to cancel out those root terms when we get to the example problems. But that's what makes it a conjugate pair. Alright, let me give you an example of a conjugate pair using numbers instead of letters to help us visualize it a little bit more. If I had 3 plus or minus 2 root 5, the pairs would be 3 plus 2 root 5 and 3 minus 2 root 5. Alright, so that makes it a pair. We have 1 and 2. The only difference is the plus or the minus. Alright, so that makes it a conjugate pair. Same thing for when we would have a plus bi. Okay, just substituting numerical values in. Alright. I'm going to show you some examples. What we're going to be doing in order to get rid of the denominator is we're going to multiply the denominator by its conjugate pair. Alright, and if we multiply the denominator, we're going to have to multiply the numerator as well. Alright, so in order to solve these, we're going to multiply the numerator and the denominator by the conjugate pair. Alright, so we're going to multiply the numerator and the denominator by the conjugate pair. I'm going to do a couple examples with you, and then I'm going to have you do a couple on your own as well. Alright, let's look at this first one. We have 1 over negative 4 plus the square root of 3. Now, we know that we cannot have a radical in the denominator, so in order to get rid of that radical, since it's not just the radical by itself, it's an irrational number, okay, it's with another number, we're going to have to multiply by the conjugate pair. Now remember, the only thing in the conjugate pair that changes is this middle sign. Okay, any sign that's out in front stays the same, but the middle sign is going to change. So if the first half of my pair is positive, the second half of my pair is going to be negative. So if I'm multiplying by the conjugate pair of negative 4 plus root 3 is going to be negative 4 minus root 3. Alright, and since I'm multiplying it by that in the denominator, I need to multiply by that in the numerator as well. Now in the numerator, it's pretty easy. 1 times negative 4 minus root 3 is going to equal negative 4 minus root 3. However, in the denominator, we now have a situation where we would need to distribute. All right, so we're going to distribute. Negative 4 times negative 4 is 16. Negative 4 times negative root 3 is going to be plus 4 root 3. Root 3 times negative 4 is going to be minus 4 root 3. And positive root 3 plus times negative root 3 is going to be negative root 9. And the square root of 9 is 3. Now you'll notice I have plus 4 root 3 and minus 4 root 3. So those automatically cancel, and I'm left with 16 minus 3, which is 13. And that then becomes our final answer. We've gotten rid of our root term by multiplying by a conjugate pair. Let's look at one other example together. We have 3 over 2 root 3 plus root 2. All right, keep in mind we have radicals in the denominator. All right, in order to get rid of those radicals, we need to multiply by the conjugate pair. All right, so the conjugate pair is going to be 2 root 3 minus root 2. All right, so we have 2 root 3 minus root 2. All right, so we're going to distribute both the numerator and the denominator. 3 times 2 square roots of 3 will give me 6 root 3 minus 3 root 2. If I distribute here in the denominator, 2 square roots of 3 times 2 square roots of 3 gives me 4 square roots of 9. Well, we know the square root of 9 is 3, and 4 times 3 is 12. Then I have 2 square root of 2 times 2 square roots of 3. That will give me plus 2 square roots of 6. Right, then I have 2 square roots of 3 times negative square root of 2, and that will give me minus 2 square roots of 6. And then we're going to multiply our last terms. Square root of 2 times the negative square root of 2 will give me the negative square root of 4, which is 2. All right, we can see that 2 square roots of 6 and negative 2 square roots of 6 cancel out, and we're left with 12 minus 2, which is 10, and that becomes your final answer. All right, what I'd like for you to do tonight is to go ahead and do 2 more example problems using conjugate pairs tonight on your own. The first one, we have 1 over negative 3 plus root 7, and the second is 5 over 3 root 2 plus root 3. Go ahead and solve both of those tonight in your notes. Please make sure they are done for class tomorrow, and we'll go ahead and take a look and go over them at that point.